Beneath Las Vegas, something is already moving. Not crowds, not tourists, not the usual chaos of the Strip. Something quieter. Something that, if you blink, you might mistake for a construction site. But what if it is not a construction site? What if it is the first draft of how every major city on Earth will move people underground? For the next 100 years. Here is what nobody is saying out loud. Elon Musk is not building tunnels. He is building a system. And there is a difference so enormous between those two things that most people have not stopped long enough to feel it. Let us start with what is actually happening right now, beneath the streets of Las Vegas. There is a network of 12-foot diameter tunnels, already operational, already carrying thousands of people per day between hotels, convention halls, and resort corridors, entirely underground, entirely electric, entirely separated from the gridlock above. The Vegas Loop, as it is officially called, already spans several miles. But here is the number that changes the conversation entirely. The master plan calls for 65 to 68 miles of tunnel, over 100 stations, stretching from downtown Las Vegas all the way to the international airport, to Allegiant Stadium, to every major node in the city. That is not a shuttle. That is not a novelty attraction for tourists. That is a city-wide underground transit grid, being built right now, largely beneath the public radar. And the permits are already being approved. More than 600 permits required for the full network, being processed at roughly one per week. Core strip construction is expected to wrap around 2027. Full system completion projected somewhere between 2028 and 2029. That timeline is not a rumor. That is an active construction schedule, moving forward, quietly, one tunnel bore at a time. Now ask yourself a different question. Why Las Vegas first? The obvious answer is that Las Vegas is permissive. Flat terrain, soft soil, a tourism economy that is desperate for faster internal movement, and local regulators who are incentivized to say yes. But the less obvious answer is that Las Vegas is a laboratory. It is the most controlled environment the Boring Company could have chosen to prove out a model that was always intended to be exported, not to other casino strips, to Los Angeles, to Chicago, to Austin, to every dense American city that is quietly drowning in surface congestion with no politically viable solution in sight. Here is the engineering reality that most coverage skips over. The tunnels being dug by the Prufrock series machines are 12 feet in diameter. Traditional subway bores are 20 to 30 feet in diameter. That difference in size is not just a technical detail. It is the entire economic argument. Smaller diameter means exponentially less material removed, less structural reinforcement required, less surface disruption during construction. Independent analysts estimate the Boring Company is cutting tunnels at somewhere between $20 and $70 million per mile. Compare that to American subway construction, which routinely costs between $1 billion and $2.5 billion per mile in dense urban environments. Even accounting for the difference in capacity between a small bore tunnel and a full subway line, the cost gap is staggering enough to reframe what underground infrastructure could look like if the model matures. And the machines themselves are getting faster. Earlier Boring Company machines were achieving around 46 meters per day. The Prufrock 2 is projected to reach 80 to 100 meters per day. The stated ambition is 1.5 kilometers per day, which would be a generational leap in tunneling speed. That target is not yet achieved. But the trajectory is real, and in engineering, trajectory is everything. Now here is where the story gets larger than most people realize. The tunnels are designed around Tesla vehicles. Today, human-driven Tesla Model 3 sedans carry passengers through the Vegas Loop at around 40 miles per hour. But the long-term plan is not 40 miles per hour with human drivers. The long-term plan is full autonomy. Robotaxis running through closed-loop underground corridors. No pedestrians, no weather, no traffic lights, no unpredictability. And because the tunnel environment is so controlled, it is arguably the easiest place on Earth to deploy fully autonomous vehicles at scale. These tunnels are not just transportation infrastructure. They are the proving ground for the autonomous vehicle future that Tesla has been building toward for the last decade. Think about what that means if it works. A network of underground tunnels in a city, running fleets of autonomous electric vehicles, carrying passengers point to point at high frequency, at cost potentially far below traditional transit, and without a single square foot of new surface land required. That is not a tunnel project. that is a new layer of urban infrastructure. The same way cities built water systems underground, sewer systems underground, electrical grids underground, this would be a mobility layer running beneath the city, invisible, self-operating, and eventually, possibly, essential. But here is where credibility demands that we slow down and apply pressure to the optimism. The current Vegas loop, despite its ambition, runs with human drivers. Full autonomy is still not deployed. There is no confirmed public timeline for driverless operation in the tunnels. Local transit officials have described full autonomy as still some distance away. The single-lane geometry of the tunnels creates a fundamental throughput ceiling that critics have not let go of. A 12-foot bore with one vehicle per direction is not a subway. It will never move 50,000 people per hour through a single corridor the way a multi-track heavy rail line can. To achieve true mass transit capacity, you would need many parallel bores and an extraordinary density of stations, which could erode the cost advantage that makes the model compelling in the first place. There are also questions about who this system actually serves. The Vegas Loop today is a tourist amenity. It connects resorts, convention centers, and stadiums. That is valuable. But it is not a commuter system. It does not yet serve the residential neighborhoods, where the workers who build these tunnels actually live. Scaling from a premium tourist experience to an equitable citywide transit network is a political and financial challenge that no amount of tunneling speed can solve on its own. And the Boring Company is still almost entirely dependent on the regulatory and geological uniqueness of Las Vegas. Other cities have harder rock, denser existing underground infrastructure, more complex permitting environments, and far less political appetite for a privately operated underground system replacing or supplementing public transit. Texas has been announced as the next pilot location, with roughly 4 miles of tunnel and 4 stations expected to begin construction in late 2026. But no other city has come close to matching the permitting momentum that Las Vegas has already built. So here is the question worth sitting with, and we want your answer in the comments. Do you believe a privately built underground electric transit network can realistically become critical public infrastructure in American cities? Or does the Las Vegas model only work because Las Vegas is uniquely strange, uniquely permissive, and uniquely dependent on moving tourists between casinos? Because the answer to that question determines whether what is being built beneath the Nevada desert right now is a genuinely civilization-scale project or an extraordinarily expensive and impressive amenity for a city that happens to have no hills and very forgiving soil. What makes this moment genuinely significant is not the tunnels themselves. It is the timing. The tunnels are being built at the exact moment that electric vehicles are becoming dominant, that autonomous driving software is approaching deployment readiness, and that American cities are becoming politically incapable of building conventional transit infrastructure at any reasonable cost or speed. The Boring Company did not create those conditions, but it is positioning itself to exploit them in a way that no other infrastructure company is currently attempting. The future being sketched out here is not one where the Boring Company replaces subways. It is one where it adds a layer that subways cannot add, a flexible, high-frequency, point-to-point underground network that runs on the same vehicles and software already being produced by the most valuable automaker in history. Whether that future arrives on schedule, ahead of schedule, or not at all depends on engineering problems still being solved, regulatory battles still being fought, and economic models still being tested. But beneath Las Vegas, the machines are already moving. And the question is no longer whether underground urban transit networks are theoretically possible at lower cost and higher speed than anything built before. The question is whether the world is ready to build them, to stay ahead of the answers as they emerge, and to understand what is actually coming before it arrives in your city. Join us here. The underground is just getting started.